Okay, so today we're going to actually utilize the skills we've been working with and actually solve equations. It's one nice thing to be able to just manipulate expressions that have rational exponents, but sometimes it's like, hey, let's put these things to use, right? Let's use our skills and solve equations with these skills. It's time for the inspirational quote of the day. Don't look at the hole in the donut, look at the whole donut. Explain about that in just a moment here. Remember our friend, that exponential table? We also have a friend called the calculator, right? Sometimes we kind of really would like to be able to do everything in our head and by hand with pencil and paper, but sometimes we rely on the exponential table, and sometimes it's like, guess what? We got to grab a calculator. Everyone kind of has their own different thing they have to try to choose from. If you need to use a calculator every single time, go for it. Use that calculator. Right? We got a little divergent situation here because I cannot predict what you will be doing post high school. Some of you may attend some type of college, right? And I got to take a look at this here real quick. Notice that they have a class called calculus, which is a very advanced math class. And then you can take 3 classes of first year calculus, spend an entire year with that. And you're thinking, some of you are thinking, oh no, that's too basic, that's too simple. Well, they also have the accelerated honors calculus for the more advanced students. So if you think, well, calculus would be too easy, I need something more difficult, my goodness, you can even do the honors, the advanced accelerated calculus. Some of you are thinking like, whoa, 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 that's the wrong direction. I don't think I want to take calculus. Well, guess what? They have calculus for students that are not mathematicians. They don't plan on being a math major. They don't plan on being an electrical engineer. They don't plan on being a nuclear physicist. So maybe you want to go to school of business or study economics, and you have to know a little bit of calculus, but you don't have to know everything under the sun. You're like, oh, okay, so they actually have a calculus class for me. And then other students are like, boy, I don't think I want to take any calculus at all. Notice they even just have some math classes for the non-science majors. If you want to go study literature, maybe you want to study psychology, who knows what you want to study. Maybe you're going to be an art major. They do have some math classes available for the students that are not planning on being a mathematician. Now, this is just from the University of Washington. They've got an online catalog. It's easy for me to access it. But depending on where you go, and I don't know if it might be a university, maybe it'll be a college, maybe it'll be a community college, maybe it'll be a technical school, maybe it'll be a vocational school, maybe some sort of a training program, maybe you'll go into an apprenticeship, right? I know that electricians and plumbers start out as apprentices, and when they master their trade, holy cow, they can go make lots of money. Same thing with welders, a lot of the trades, right? You don't have to have some super duper advanced math skills, right? And so who knows what you're going to do post high school? If I found 10 different high school seniors and said, what are you doing after high school? I'd probably get 10 very different answers. But if you do find yourself going to some type of school after high school, don't let math kind of be like a stumbling block for you, right? It's like, hey, there will be a math class that will serve your need, right? So if you have to rely on a calculator, go ahead and rely on a calculator. There's no problem with that, right? We've got students that move on from high school and move on from college. They go on to live happy lives, fulfilling lives. They make money, and they can do it without advanced math skills. Go ahead, take a deep breath, use the calculator. You can do it. We're not going to lose you, right? Look at the donut, not the little tiny piece that's missing in the middle, right? So if you are, however, thinking of like physics, engineering, computer science, or some math related field, I recommend you try to do all the work by hand using your brain. But if you're like, hey, you know what? I don't know what I'm going to do, but I don't think I'm going to be like an electrical engineer. I'm not going to be a nuclear physicist. I'm not going to be a mathematician. Grab that calculator. Use that calculator. Push the buttons on the calculator. We're also going to be solving equations for this set of real numbers, which means our imaginary friend I is not going to come into play. I is going to kind of wait around for a while until we get to another unit. I know we looked briefly at it already, but it's going to kind of go hang out on the shelf for a while. So we're not going to use the imaginary number I. Quick reminder on the real number system are natural numbers, right? That's what you can count on your fingers, 1, 2, 3, 4, 5, etc. The whole numbers, that's when we introduce the concept of 0, 0, 1, 2, 3, 4, 5, etc. The integers, well, they're just like the whole numbers, except we can also have the negatives. Notice the number 0 is not positive, it's not negative. If you've ever wondered why we use a z for integer, that's from a German word, Zahlen. Right? When I was growing up, we used j for integer. It came from some other word, but we're kind of a global community now, and more mathematicians are agreeing on z for integer. When I grew up, we used a capital R for rational. It's much more common now to see Q because you can write it as a quotient, right? A rational number can be written as a ratio, in other words, a fraction. And of course, in higher math classes, we view a fraction as division, right? Top divided by bottom, right? Numerator divided by denominator. So since we can write it as a quotient, we use Q for rational. I for irrational, those are numbers that cannot be written as a fraction, right? So those are your decimals that do not terminate and your decimals that do not go into a repeating pattern. Put all those together, we get the real numbers. And again, to differentiate the real numbers from the rational, we usually use a fancy script R. So if you're ever reading a math book, whether it's a actual paper math book with a binding and a cover, or a math book that's on the internet, or just a math website on the internet, if you see that script R, they're talking about the real numbers. Also, our friends, the purple elephants, merrily dance after sunset. Or maybe you learned the purple ears make dairy animals super. A hot one in the Pacific Northwest, parachuting emus may drop around Seattle. Some of you didn't learn any neat phrase, you just learned PEMDAS, right? You said, hey, I know what's going on. It's parentheses first, then exponents, and then multiply or divide from left to right, and then finally add or subtract from left to right. Of course, if we're solving equations, though, we actually reverse the order, right? If we want to solve an equation, we have to start by undoing the adding and subtracting. Then we undo the multiplying or dividing. Then we undo the exponent. And then anything that was inside the parentheses, we go in the same order, right? So outside the parentheses, look for adding or subtracting. Then look for multiplying or dividing outside the parentheses. Then look for any exponent outside the parentheses. And then finally, if everything outside the parentheses has been taken care of, you can go inside the parentheses and start all over using the same progression. Okay, so let's get to some examples here, right? You've probably fallen asleep at this point, so we better get going here. Okay, do I see adding or subtracting outside of the parentheses? Yes, I do. I see a minus 13. Opposite of subtraction is addition, so I'll add 13 to each side. Notice on the left-hand side, the only thing that happened was that the negative 13 and the positive 13 canceled. Do I see multiplying or dividing outside the parentheses? No, I do not. Do I see an exponent? Yes, I do. How do I undo an exponent of 5? Raise it to the 1/5 power. Because those exponents will cancel out, right? 5 times 1/5 is 1. Anything raised to the 1 power, I can forget about the exponent. It's going to be itself. Notice nothing happened to the 3x plus 8, right? I just canceled the exponents on the left-hand side. I'm not quite done with this step because what on earth is 32 to the 1/5 power? That's just 2. Hey, the parentheses are gone, so let's start all over. Undo the adding or subtracting, and then undo the multiplying or dividing. Okay, look for any adding or subtracting that's not inside parentheses. I can subtract to undo the addition. Look for any multiplying or dividing that's not inside parentheses. I can divide to undo the multiplication. Now, the tricky part. Undo an exponent of 4. I'm going to do the 4th root, but look what shows up. When I decide to take an even root, I don't know if the variable is thinking about positives or negatives. I have to put the plus or minus in front. Of course, the 4th root of 16 is just 2. So I've got 2 answers. One of them is positive 2, one of them is negative 2. Right? If I take an even root, I have to put the plus or minus. All right, I see a subtract 7, so I can do the opposite, which is adding 7. I can't touch the plus 4 yet because that's inside parentheses, so instead I have to undo the exponent. So I have to raise it to the 5/3 power, right? That's the reciprocal. 3/5 raised to the 5/3, cancel each other out. Leaves me just x plus 4. Cube root of 8 is 2. 2 to the 5th power is 32. Now I can subtract the 4, and I get 28. Remember, if I ever go through any of these examples too quickly, you can also replay the video, or you can look at the PDF of the examples that's available on Schoology. Triton, quiet. We'll go for a walk in a minute. Good grief. The only thing outside of the parentheses that I see is an exponent of 2/3, so I'll raise each power to the 3/2. Now again, because I need to take an even root, right? 2 is an even number, and that's the root. I have to have the plus or minus in front of that 9. So if I take the 2nd root of 9, I get 3. If I raise that to the 3rd power, I get 27. And now I'm thinking, oh, wait a minute here. What am I supposed to do? I've still have this 2x minus 1 going on. Am I supposed to solve it for positive 27 or negative 27? Well, of course, both of them. We need to set it equal to negative 27. We also need to set that equal to positive 27 and find each of these solutions. I can add 1 and then divide by 2 and get negative 13. Or I can add 1, divide by 2, and come up with a positive 14. Whew, what a lengthy video. And my dogs tell me we gotta go for a walk. So there's some cats for you. And of course, as Yoda often lets us know, extra paper is probably going to be your best friend here, right? Your work may not all fit on the worksheet.